Coding. Okay, for this question, Mr. Ismail, please join me on this question number 24. Read. Go.
There are 5 red pens, 3 blue pens, and 2 green pens in a box. Gary takes at random a pen from the box and gives the pen to his friend. Gary then takes at random another pen from the box. Work out the probability that both pens are the same color.
Okay, so let's try to pick up key words and key things that have been said here. So we got 5, 3, and 2. How many do we have altogether?
10.
So we have 10 items. So the fraction will be out of
10.
Okay, Gary takes a random pen and gives this pen to his friend. Okay, this is very important at the wording. He gives the pen to his friend. So what does that mean regarding the next pick?
It's without replacement.
Fantastic. Well spotted there. You have to spot that in the exam without replacement. The wording is not saying explicitly, but it is implying it explicitly. Okay, it's not saying without replacement, but if you take something out of a box and give it to a friend, you definitely haven't put it back in. So it's without replacement. So what will happen to the fraction in the second part of the question?
It'll be over 9.
It will be changed, be over 9. Fantastic. So there'll be 2 parts of the question. The first part and the second part. Lovely. Okay. So what is the probability of red anyway?
5 over 10.
And the probability of a blue?
3 over 10.
And the probability of a green?
2 over 10.
Fantastic. Okay. So now it goes back to the probability that both pens are the same color. Now, what does that keyword both indicate?
And.
Lovely. Both pens means the first one and the second one being the same color. So can you give me some annotation now? Give me the idea. So what is the idea?
The probability of red.
So big P of red, yeah?
And then add big P of red again.
Fantastic. And then what's the next word?
Or big P, small
P.
Yeah. And then again. Then the O again.
O.
For green.
Big P and G.
Yeah. Lovely.
Fantastic. Now this idea part, it's overlooked. Most students don't do it. But I say to you, it is absolutely imperative. It is essential. It is compulsory if you want to get your exam paper questions technique mastered. So now, Mr. Ismail, put a layer of maths on it for me now, please.
You do 5 over 10 multiplied by 4 over 9.
So 5 over 10, the and means multiply. What happens to the red? Why have you dropped it to 4 over 9?
Because it says he gives one to his friends, so then that means 1 less.
So he's given one, the red one that he's picked to his mates. So he's got 4 ones left. So he's lost 1 red and he's lost 1 in the total. Is that right?
Yeah.
Okay, lovely. What does the O mean?
You add it.
Put a big, massive add. And what is PB? Probability blue?
3 over 10.
3 over 10?
2 over 9.
And then you take 1 out, you lost 1 of them. So you got 2 over 9 now. What's O mean?
Add.
Big fat add. And what's probability green is?
2 over 10 multiplied by 1 over 9.
Fantastic. Okay. Abu Bakr, are you happy with that?
Yes, sir.
Okay. Any mistakes in it?
No.
No, inshallah. If you spot a mistake, tell me straight away. Because we don't like doing editing. Editing is for people who got too much time spare. We want to make a fantastic video first time round and smash it up and upload it. Okay. So we need to go through that. Ismail.
Well, yeah, I'm working out.
Okay, so I don't want you to cancel anything down. What's 5 times by 4?
20.
Over?
90.
Plus?
6 over 90.
Plus?
2 over 90.
Fantastic. Right. Let's finish it off.
28 over 90.
That gives me 28 over 90. Can we cancel that down?
Yeah.
Okay, what will that give us?
14 over 45.
Yeah, that's right. 28 over 90. You divide them both. What do you divide them both by?
2.
Divide them by 2. Fantastic. Lovely. How many marks are that worth altogether?
4.
4. Okay. Now, what was the key for us doing this question properly? What do we have to do first?
You have to read the question carefully and understand what's on.
Absolutely. Read the question carefully. Understand the key words, what's happening. This part means that. We're going to have this style of question. Both means and, which we've got over here. The ands are here. Okay. Now, what was the other important part that we have to, in order for you to do the question properly, what do you have to do?
You have to
Get the
Yeah.
what right? What's this part called?
Plan. Idea.
The idea. Get the idea part right and annotate. So what we've written there, that's mathematics with symbols, probability of red and probability of red, or probability of blue and blue, or probability of green and green. That's been written down for you to tell yourself what you're doing. Okay, now the fractions started changing, 10 to 9, 10 to 9, 10 to 9. Multiply them all, add them all up. Bob's your uncle James, your auntie job's done. Fantastic. Thank you very much for that. Okay, question number 25, new question. Question number 25. Question number 25. You need a, I need a tiger for this question.
So can I do it, please?
Okay, is that Ismail?
Abu Bakr.
Abu
Okay.
Bakr, mashallah, Kabul. Yes, yes. Okay, right. This question will come across a concept that I'll see if you can give it to me, otherwise I'll have to give you that particular concept. Read the question first, please, and let's think about how we're going to deal with this particular question. Go on.
Caroline has 20 biscuits in a tin. She has 13 plain biscuits, 5 chocolate ones, 3 ginger biscuits. Caroline takes at random 2 biscuits from the tin. Work out the probability that the 2 biscuits were not the same type.
Okay, now, so what is the key bit that we are looking at here?
They're not the same type.
Not the same type. Now, each worded question has its own implication style. So when it says not the same type, that kind of straight away I start thinking about stuff like this. So the probability, for example, of winning and the probability of losing is always equal to what?
1.
1. Fantastic. Or we can say the probability of winning and the probability of not winning. So the probability of something happening and not happening is always equal to what?
1.
1. Fantastic. So have I given you a little clue to how we do this question?
Yeah.
Right. Now, so the clue is this then. So the bit of the puzzle is you working out this bit.
Yeah.
So how do we work out that bit then? From the words to that, how do I work that out?
You're going to work out how much they are of the same type.
What's and mean? So now here, I'll put and out. Actually, probability of winning, or I've actually used the wrong word in there. Apologies for that. I should have put in here an or. Probability of winning or the probability of not winning is always equal to 1. So if we look at those 2 different combinations, now what are those? The or can be changed straight away into
Plus.
And I want to work out this bit here, which is this bit. How do I work out this bit here? What do I do?
You find out that one there.
So the probability of, in this case, would be not winning or not the same. Would be equal to 1 minus the probability of it being
Winning.
the same.
The same.
So this here is a particular style of how we can answer probability questions by knowing that fact. Probability of something happening and not happening added to 1. Okay, so that's a concept that we need to have, the idea. From the idea, we can manipulate that and make it into what we want it to be. So I could actually be a little bit cheeky and go and change those not wins into not same and probability of not the same. Okay, I'm going to stop right here. Is everybody in the class happy with what we've done so far? I'm just bringing a little bit of a new concept.
Yeah.
I'm sure you kind of realized it before, but I'm kind of bringing it into its own kind of in this question, so we can do the question, inshallah. So let's have a look. Let's do that then. So the probability of not the same is equal to 1 minus the probability will be the same. So what? Can you give me some annotations, Abu Bakr, that goes into here of the probability of the items being the same?
Plain.
Probability of plain and
plain.
Beautiful. And the next word is
PC.
or probability of
PC times PC.
Okay, the dog put in the times here, and probability of chocolate or
PG.
PG and
PG.
fantastic. So this bit here is you now coding the maths for yourself for when you're sitting in the exam, rather than you have to write big sentences and things. Lovely. So let me get rid of this from here. Right, okie dokie. Right, let's go. So let's start putting now. Start layering in for me the maths now. Put the maths in now. What's the probability of a plain chocolate?
12/20.
Now we know that the two.
Times.
It says that the two bits are taken from the tin at random. Are any of them put back in?
No.
No, that's because of the way the sentence is. Two bits are taken out. So this question is
Not replaceable.
so.
Without replacement.
Yeah, it should be no replacement.
Okay.
Okay, no replacement. So we're not replacing them. So what happens to the second when you pick up the second chocolate, the plain one? What happens to the bottom number?
Take away 2.
Take away 1.
Oh, 1.
We don't take away 2 because this is for the first biscuit. That's for the second biscuit. So from here to here, we're minusing 1, and from here to here, we're also minusing 1.
1.
I understand what you're saying. Take away 2 because you're thinking about the 2 biscuits. But for the first biscuit, the original probability holds. It's only for the second biscuit that we have to do our adjustment, Abu Bakr, and we do the -1. Okay. We only do -2, Abu Bakr, if we took out 3 biscuits, for example. If we took out 3 biscuits, we return to 10 over
18.
Yeah, that's the time you take out 2 biscuits. If you're on the third level, the third biscuit. But because the question is not like that, I'll just showing you when it would be that case. Okay.
Okay.
So let me get rid of all this extra stuff here because it just clutters everything up. All right. Okay, go on the next bit now.
It would be 5/20.
Don't forget the O means
Plus 5/20 times
5/20 times by
4/19.
beautiful.
Plus,
and then the last bit
plus 3/20.
3/20 times by
2/19.
2/19.
Yeah.
Beautiful. Okay, let's start putting this together now. So you got 1 minus what's 12 times by 11?
132.
20 times by 19?
380. Yeah, 380.
380?
Yeah.
19 times by 2 is 38.
Mm.
Okay. Give me a second. Yeah. Okay. And the next one?
20/380.
And the next one?
6/380.
Okay, what we could do, here is this one.
Divided by 2.
There we go. Like that. So what's 132 add 20 add 6?
158/380.
If we can't use our calculator to work this out, which we'll use calculator last. Let's see how would we deal with this question. How would you do this question right now if you were to do a pen and paper method?
Simplify it.
So what's 1 the same as?
380/380.
Yeah.
Minus
You're making them equivalent.
158/380.
Yeah, which gives us what?
232.
222.
222.
Yeah. That will give you the 380. Yeah, over 380. Now, what will can we cancel that down?
Yeah, 111/190. And that's the answer.
Wow, that was a handful. That was a mouthful. That was. Well, let's just quickly double check our calculations on the calculator. So you start with 1 minus fraction button, and we have 158. Replay, bring the cursor to the bottom. 380 equals, and that gives us the answer straight away as a check. That's done. That's lovely. Are the questions getting a bit more exciting now, Abu Bakr?
Yeah.
You see the method. It's all about understanding the question, what they're talking about, interpreting it, and having the right idea, and then putting all the maths together. Okay, lovely. I think we've come to the break time. I'm just gonna pause our video. Okay, read question number 6, please. Go.
Pfizer has 10 coins in a bag. There are 3 £1 coins and 50 7 50p coins. Faiza takes at random 3 coins from the bag. Work out the probability that she takes exactly £2.50.
Okay, so first of all, I want you to look at this sentence and tell me from this sentence what's implied. Is it a without replacement or with replacement?
Without replacement,
Okay, so why do you think that?
because it says that she just takes them. It doesn't say.
That's right, absolutely. So this is without putting them back in. So that's a very important deduction that you made there. She takes them out of the bag. So obviously say one out and then the second one out and then the third one out like that. So she's not putting them back in. They haven't told us to put them back in. So we assume that she hasn't. Okay, now, what about this word here? There's another key word. What's that word mean?
Exactly. £2.50 means like you're not estimating. It's bang on.
Okay, so exactly 2.50 means it has to be using those 3 coins. It can't be more, can't be less. It has to be that value. So give me some annotation now. So how do I work out the probability of 2.50? So it could be probability of what? Give me the values. Probability of £1 and another one
Yeah.
and
50p.
or what's the other way? Give me another way of doing it.
50p, 50p, and £1.
Okay, now probability. You can't use 50p more than once.
Oh, probability of £1.
So probability of £1 and
50p.
and £1 again, yeah?
Is that not the second? Oh, no, never mind. Yeah.
Yeah, that's the second combination. Give me the third combination.
50p.
Probability 50p first, and then
Of £1,
and then
and again.
fantastic. Right, Ismail, are there any other ways of making the £2.50 using those 3 coins?
No.
Good, excellent. That's well done. So this part here, Layla, what would we call this part here that we're doing? This important part here, this annotation that we've done. This bit. Well, what do we call this part normally? This is called our idea.
Mhm.
Now, do we need to do an idea each time we do the question?
No.
Yes. You need to do the idea if you want to pass the exam. If you don't want to pass the exam, don't do the idea. Just do random calculations, write anything down in any order, and you're definitely going to not get that one right.
But you only use one of them, don't you?
No, idea means this is what we're going to do. No, it's all 3 of them.
Yeah.
Work out the probability that she can takes exactly £2.50. So there's 3 ways of making exactly £2.50.
Yeah.
It's all 3 of them. It's not. We're not going to just. I'm not giving you like a choice like you in a restaurant. Do you want to have chips or do you want to have beans?
No,
or do you want?
I know that.
Yeah. Are you happy with my explanation? It's all 3. Yeah.
Yeah.
So it's either the first one, or it could be the second one, or it could be the third one. So we have to translate all this language now into mathematics. So quickly, what does the O mean?
Add.
Big fat add. What's the O mean?
Add again.
Okay, what do all the ands mean?
To multiply.
I'm replacing all the ands above with times below. Okay, what's the probability of my first pound?
1 out of 10.
Probability of the first pound, how many pounds do you have?
3 tenths.
3 out of 10.
Sorry, yeah.
And what about the second one?
Same, 3 tenths.
2 ninths.
1/8. Is 1/8 the next one?
And
No,
the next one's going to be out. The next one, probability of 50 will be 7 out of 8.
I don't get that.
I'll explain to you now then. So each time we take a coin, out, we're losing 1 from the bottom. Are you happy with that, first of all?
Yeah.
Oh, because you take coins out. Right.
Yeah, because you're taking the 3 coins. For example, you take the first one, second one, third one. So when you take the first one out, before you take the first one out, there's 10 in the bag, so the probability is correct for the first bit. Then you got 9 in there. Now you take the second one out, so the next probability will be out of 8. So every time you take a coin out, you lose 1 value from the denominator.
From the total.
Now, from the top part also, because you took £1 out, you have 1 less pound to choose the next time.
Yeah, I get that.
Now, these 2 are not connected. These 2 are not connected here. I'll rub that off now to get out of the way. Because the 7 guys is its own entity here. Look, 7. We haven't touched them. We haven't dipped into them yet. So that stays as 7. So nothing is happening here. Nothing is happening in this part here of the calculation. Okay, done. Fantastic. Right. The next part, Layla, probability of the first one is going to be
3/10.
yeah 3/10 again, and the probability of the first 50p
1,
7
7,
out of
9.
9. Lovely. And what's probability of the of another pound now? I've already taken 1 pound out earlier.
2 out of 8.
Lovely. So we can assume we'll bang them all in. Let's smack them in there. 10, 9, 8, 10, 9, 8, 10, 9, 8. Smash. Okay. That's the style. So what about the last one? The probability of the 50p
7.
and the probability of the first pound
3.
and the second pound.
2.
Fantastic. Lovely. Beautiful. Okay. Is it making sense now?
Yeah. Now I get
Okay.
it.
Okay. Good. Let me get rid of some of this extra boom stuff here. Get it out of the way because it just clutters things up. Right. What's going to be the first bit, the second bit, and the third bit? So 3 times by 2 is 6 times by 7 is
3 times by 2 is 6 times 7, 42. Yeah.
42 over.
90 times 8.
Yeah.
720, 72. Yeah, all the way.
So does it look like the same number each time?
No, wait.
Yeah.
Yeah.
Lovely. So what's the total then?
4,226.
Okay, we can cancel that down, obviously. Oh, look, you just cheat a bit. I mean, you can always do that. I'm sure some of these are in a calculator paper. I can't remember which ones. Okay.
It should be anyway.
We use a little bit of calculator assistance, like it's like a hybrid question. So what's our final answer?
Just half it. 7. Oh, yeah, 7 out of 40.
So you can divide it multiple times by, at the moment, the number 6 will go into them. So 126 divided by that, I'll give you what? I'll give you 21.
Wouldn't it be 7 out of 80?
G?
Wouldn't it be 80, not 40?
Okay, we'll just show you. Well, that's what the calculator is giving us, 7 out of 40.
Yeah, that's the right answer, sir.
Yeah, okay,
7 40.
so 72 divided by 6, that will give you what? 120. And then you divide that by 3, divide that by 3, and that gives you the answer. Yeah?
The calculator says out of 80.
The calculator is right in front of you. Oh, can you see? Hang on a second.
No, you can't. It's not that.
You can't see my calculator?
Nah.
Okay, give me a second. I don't know why it's Zoom recording. Okay, so the answer is correct, Layla. It shouldn't be 80 in the bottom, it should be 40, okay?
Just write the whole thing out in the calculator, you get 7 over 40.
Yes, and the final answer is 740, yes, that's right. Okay, are we happy with that question?
Yeah.
Okay, lovely. Okay, so do you see how much? I mean, I know I write big. I think writing big is a bit of an understatement, but that question takes the whole page.
Yeah.
To show your understanding, what you're thinking, how you interpret the ors into pluses, the ands into times, your mathematical annotation and idea. It's all important. Okay, here comes the fun question. Question number 21. Ismail, please join me on this question.
There are 10 pens in a box. There are X red pens in the box. All the other pens are blue. Jack takes at random 2 pens from the box. Find an expression in terms of X for the probability that Jack takes 1 pen of each color. Give your answer in its simplest form.
Okay, so if he takes at random 2 pens from the box, is it with or without replacement?
Without.
So what happens to the number on the bottom?
It will.
It starts off first of all 10, and the second part will be?
Or 9.
Okay. So it's definitely without, and it's going to be of this style. So that's something we can tell ourselves straight away in the beginning. Now, how many pens are there in the box altogether?
10.
Okay. So let's try to make sense of the algebra. What's the probability of getting a red one?
X over 10.
Okay, lovely. And what's the probability now? The next part of the answer, I don't want you to verbalize it. I want you to send it to me in chat, please. I want to see what everybody else is understanding. Everybody now, probability of blue, no verbal answers over the audio. I want a text answer, please. I want to know what's going on here. Give me the answer, please, in the text. I want to see not just your answer. I want to see everybody else's answer. Oh, Ismail's answer. Okay. Ismail, I like your answer. Nobody can see your answer anyway. Oh, Abu Bakr, your answer is exciting. Okay, Ismail, I think there might be one part of your questions incorrect. You need to look at your denominator, Ismail. That's all I'm going to say to you, clue. Okay, Abu Bakr, yours is, whoa, that's heavy. Oh, Layla, oh my days. Ismail, you hit it, mashallah, superb answer. Correct, well done. That's the reason why I wanted you to give me an answer, not orally, because then everybody will just copy your answer. Ismail, your answer is correct. Jazakallah khair, that's very good. So your answer, okay, now I want you to help me develop the answer to explain to the other students how you got to there by doing very simple, easy steps. Now, your answer is, I'll give them your answer, first of all, in its full beauty. What a beautiful answer. Okay, so you got 10 minus x over 10 is the probability of blue. Now, Ismail, can we just make it really simple? So so for example, the red pens add the blue pens, is that right? What do they add up to?
1. No, sorry, 10.
Just the number of pens, yeah? So the red pen add blue pens 10. And how many red pens do we have?
X.
And the blue pens, we don't know how many they are.
Yeah.
So how would you work out the blue pens? And I highlighted for you here. How would you work out the highlighted question mark orange box? Because I want to know how many there are. What do you do?
10 minus x.
So the opposite of adding x is?
Minus.
So the number of blue is equal to 10 minus x. And that is where this part of the answer comes from. So we have x red pens and we have 10 minus x blue pens. Okay, so that's important to understand. If they give you something in algebra, how do you work at the other bit in algebra as well? So the easiest way to do it is this particular way that we just done now, is to try to understand what's actually happening. I have x red pens plus so many blue pens. The total is 10. So to work out the number of blue, opposite of adding x is minus x. That's our straightforward algebra that we learned from maybe key stage 2, key stage 3. Okay, first of all, is everybody happy with us having 10 minus x blue pens?
Yeah.
Yeah.
So that's the most important part. We have to be able to go from this to this. And then we get to the part, the probability part's easy because it's out of 10. It's x out of 10. That part isn't the difficult part, is understanding the 10 minus x, what the origin of the 10 minus x is. So well done, Ismail. Second time around, not bad, alhamdulillah, that's good. Okay, so let's kind of get this towards one side because I want to just move this away and make some space. So, right, okay. Now that we understand how many red pens we have, how many blue pens we have, what the probability of red is, what the probability of blue is, we are now in a healthy situation that we can do the question. So, Ismail, without any further delay, now do the question. What we were just doing was the background, was doing the foundation work. Now you should be able to do the question. Off you go.
It says takes 1 pen of each color. So does that mean?
So come on, give me the annotations and what do I write down?
The probability of red.
Probability of a red and probability of
a blue.
A blue. That's one way you get different colors. Or
probability of a blue.
Or probability of a blue first.
And then probability of red.
And then the probability of a
red.
Red. Absolutely. What do we call this bit here that we just done together?
Idea.
And do we need to do the idea for the question?
Yeah.
It's essential. Okay, that's our idea. Important. Please, folks, do not miss out the idea. The idea is absolutely essential. And I'm going to just make it nice and beautiful and colorful. Done. Now, put the layer of maths onto it now, Ismail. Now, the stuff that you said, we said here earlier. Oh, hang on a second. Let me just get rid of this first, this bit here. Oops, I got rid of too much. Okay. Now, this is the probability of red. and this is the probability of blue. So now use those the algebra that we formed, and now start putting in here. Now off you go. So what do we do here?
X over 10 times y.
X over 10 probability of red, time by
10 minus x
over
10 over 10.
Oh, hang on a second now,
Actually, 9, 9, 9.
because it takes one pen of each color. So did you put it back in?
No.
No. So even though the top probability is absolutely correct, we have to adjust it for this context, the blue part. So
Yeah.
yes, the probability of a blue is 10 minus x over 10, absolutely correct. But because we're not replacing it, that 10 becomes a 9. Absolutely correct. Put a big plus here, big fat plus. Okay, what's the probability of the blue for the second part?
Is it 10 minus x over 10?
And what's probability of the second one being a red?
X over 9.
It'll be x over 9. And that is fantastic, lovely. So we have to go from 10 to 9 by minusing 1, because we're taking them out after each other. So it changes the bottom number. Okay, lovely. Right, let's get rid of this stuff now here. Now, come on. We've got algebra now. Let's not feel scared now. Let's just deal with it.
10x minus x squared.
That'll give you 10 minus x over 90. Is that right?
Yeah.
Plus the same again?
Yeah.
Okay, right. So now, can you make that nice and beautiful for me now, please?
It's 10x minus x squared.
Okay, now just think about it. If you have one of these, add another one of these. How many of them do you have?
2.
2 of them. Done. Something as simple as that. We are just don't overcomplicate anything. You're doing algebra. Yeah.
Right.
You have
Yeah.
one lot of them, and you have just 2 lots of them. What can you do with the 2 and the 90?
Right.
So what's my final answer over here?
10x minus x squared over 45. Are you not supposed to expand it?
Well, it did say give it in the simplest form.
Okay, yeah.
Remember, factorize is something that makes it
Yeah.
makes it the simplest form.
All right, yeah.
Yeah, we happy with that?
Yeah.
That was an awesome question. I love that question. And you get a lot of those in these days in exam, but they slip a bit of algebra in there. So don't get scared with the algebra. Deal with it. Yeah. You got to man up or girl up and deal with the question. Okay, we got one last question over here. Question number 23. Whose question? Layla. Okay.
Abu Bakr.
Abu Bakr Saab. Okay, make it nice and big for you. Okay, Mr. Abu Bakr, read the question. Let's smash this one up.
There are 7 blue counters, 3 green counters, and 1 red counter in a bag. There are no other counters in the bag. Hubert takes random 2 counters from the bag. Work out the probability that the both counters are blue.
So straight away, this part here, whoa, that's a really big, thick highlight. Okay, let's try again. Right, so what does that mean? 2 counters in the bag. Is it with or without?
Without.
Without. So the fraction, we got a 7, a 3, and a 1. What's 7 and 3 and 1?
11.
So the first part would be 11, and the second part would be what?
10.
Fantastic. So you're telling us that straight away in the beginning question. It's going to be 11 and a 10 question, not 11, 11. Okay, remember that. That's excellent. Note.
7, 6.
So both kinds of blue. So probability of a blue and the probability of a blue. This is our annotation. This is our idea. Okay, that's what they told us. This is what we write down. Okay, now what's the probability of the first blue?
7 over 11.
7 over 11. What's and mean?
Times.
Because when they mention both means and means times. So what's the second one going to be?
6 over 10.
Fantastic. What's the answer going to be?
So 42 over 110.
Can we cancel it down?
21 over 55.
Okay, Ismail, are we happy with the answer?
Yeah, I'm happy with it.
Layla, happy?
Yeah, I'm happy.
Okay, good. All right. Okay. Work out the probability that the two counters are different colors. Now, you remember something that we just done earlier when we had this something not happening and happening. Remember that? I'll remind you. Take it back up there.
Mutually exclusive.
You remember when we done this stuff here?
Yeah.
Yeah, that concept. Right.
Okay.
So back to here. So probability counters are different colors. So probability of different and the probability, we say, or the probability that the probability will be the same. What do they always add up to?
1.
1. So if you want to work out the different, what will it be?
Probability take away 1. They're the same, take away 1.
Not the same take one, but 1 minus the same, other way around.
Mm-hmm.
Do you understand the significance of Abu Bakr?
Yeah.
Yes?
Yep.
It's always 1 minus, yeah? So let's do that then. So the probability of different colors is 1 minus, put some layer of maths now into it. What's the probability of being same? So what could they be if it's the same? Probability
Blue.
of blue and
Blue.
or
Green and
probability
green.
of
Green and green.
green and probability green or
Red.
now, you know when I'm saying or and I kind of make it really big or, you need to say that to yourself in your head. Okay, if you don't say that word or to yourself in your head and you don't write it down, you're going to miss it out and then you're going to get it wrong. Okay, it might sound like, oh, sirs, you know, oh, sirs having a good time teaching maths. It's not about that. It's about you understanding the work. It's this probability or that one. You are reminding yourself about the or effect in it. It's an or in there. What's the last one? Probability
Red.
of a red and a
Red.
lovely. Let's put some more maths onto it now. So 1 minus, what was the probability of a blue?
7 over 11.
7 over 11 times by
6 over
10. And what does the or mean? The or?
Plus.
That's it. You got to keep on telling yourself, and means time, or means plus. You're not making any mistakes. What's the probability of the green?
3 over 11.
Time by?
2 over 11.
And what's the probability of the red?
1 over 11.
Time by?
0 over 10.
Yeah, you can have that. That's okay. We're doing
going to be
maths.
0.
Yeah. Give me a second. I think there's a bit of lag between the
Yeah.
Yeah, just give me a second. That's not due to the Wi-Fi. Let me just pause the recording for a second. And then I normally, if I just switch the Wi-Fi off. Okay, I'm just going to make this a little bit smaller because I was right so big, I just run out of space. Okay, and I can do that. You guys can't. Okay, right, let's get back to it. Okay, back to Abu Bakr. 7 down by 6 is?
42.
Over?
110.
3 down by 2 is?
6 over 110.
And 1 down by 0 is?
0
over 110.
So what's 42 at 6?
48.
100.
Now 1 minus 48 over 110. How do we do that?
110 minus 48.
So this one will be
47.
one is the same as what?
110 over 110.
100. Yeah, that one. Oh, so it's only
62 over
52 over. Yeah.
60.
So that'll give us what number?
52.
110 minus 48 will give us, are you sure it's 52?
No.
62.
Yeah.
62. That's better.
Oh, yeah, 60. 60.
Yeah. And then what do we do that? Divided by?
2. 31 over 55.
And I want to double check on the calculator as well. We can just check that calculation. Where's my calculator? Okay. So 1 minus, we got that fraction button 48, replay, 110, boom, fantastic. Okay, lovely. How do we feel about those questions so far then?
Good.
They kind of open our eyes a bit about how we deal with the questions.
Yeah.
Yeah, we have to deal with the question depending on the wording. It's all in the words. What they say, both. So 2 counters from the bag means that they take them at one go. You have to be able to interpret the language of the examiner and see what is he saying to me. What does that mean to me? How do I interpret that? So it means this. That's my idea. And you start putting the layers of the maths onto it. Okay, that's the end of at the moment that stuff. That's all the exam questions I wanted to do, including the easier ones that we done earlier in the easier video. So we've got that stuff at the moment. Okay, right, we're gonna stop this video here.